I wanted to collect some ideas about Xen configuration best practices because as the distributor, we at SUSE have often the problem that customers are not very happy with the default settings of the configuration for the hypervisor or the zero kernel or the guests. So basically, there are four main areas for configuration: the hypervisor boot parameters, the DOM0 boot parameters, the guest default config options, or some other config options which are not default, of course, and the general setup variant, so how the complete setup is working. And I wanted to suggest to collect some data from all the companies or providers or whoever's here in the Xen community having the same problem. So configuring customers' Xen machines. And I'd like to have a collection in either a wiki page or wherever and extend that as a living project, basically. Another idea might be if there are common solutions for different providers that we could have some additional patches for extending the configuration possibilities, for making it easier to automate those settings. The basic idea for this design session came up when I tried to upstream a patch we were considering at SUSE when it became obvious that large guests have not enough event channels per default. So when you have, let's say, a guest with 64 or 128 virtual CPUs, you soon run out of event channels because already the per CPU event channels are more than the normal configuration or the normal default would allow for. But unfortunately, because it was not generic enough, this patch was rejected. So I thought about maybe combining forces, basically, or making better documentation that it's easier for customers to set up a complete environment. Okay, so
I think this would be an excellent idea.
Yeah, so basically there was a customer manager who came to us to the development and said, well, what would you suggest how to configure the systems? And as a developer, this is often very difficult to decide because often enough we are lacking the knowledge how to set up productive systems, right? And I think collecting the best practices from different companies, providers, and so on is the best way to go. And if we have an upstream document, it's much easier to reason at the customer with the customer. So look here, there are upstream suggestions how you should configure your system. This is the best way to go, and they're not asking, well, are you sure this is the best way? Doesn't Citrix do it differently, or Debian, or Amazon, or whoever? So I think the main issue is we should decide where to collect this data. Should it be an upstream document in the XenGit? Should it be a wiki page or whatever?
With my documentation hat on, definitely something upstream in Sphinx. I don't know if we've got Stefano around at the moment. There is currently quite a lot of work that has been contributed from Xilinx to try and help us get a better start on some of the Sphinx documentation. So hopefully we'll be getting that sorted sooner rather than later. but it's mostly structuring and moving a few bits and pieces from the wiki. But I think this is absolutely something that should live in upstream documentation in Zen.git that can be worked on and pointed to, and isn't something. It isn't a wiki with a billion different options in it.
I agree with that, because there are options which are added depending on Xen versions, and depending on the Xen version, the best practice might change. And the wiki, we always get the issue that it's never up to date.
Yeah, whereas Sphinx in particular, Read the Docs, which is one of the things we use specifically, has the notion of versioned documentation. In fact, the default renderer I've got for dev patches already understands 3 different versions of Zen documentation. They happen to be all fairly similar because not much change has been made, but that's something that Sphinx natively understands.
Also, with the Doxygen contribution, the look and feel of the generated documentation in HTML might be better, which means we could introduce things like that directly. So ARST rendering and etc. will be a bit better, and the browsing the documentation will be better.
And we can probably have one consume the other or whatever. They're both common open standards. I'm sure we can make something work there.
Yeah, Doxygen can consume the RST and feed it into Sphinx. Means we can generate one pack of documentation which contains everything for each Xen releases.
I think the format could be discussed later. I think we should first try to settle what we want to cover, which different scenarios or use cases do we want to cover, and so on and so on. So this is, I think the final format is something we can easily settle by Extendable or something like that.
Yes, the final format should be the last thing nitpicked over, not the first thing.
Yeah, right. So I think Zen.git seems to be agreed on, and I think I agree here as well, because in the wiki this will just bit rot basically over time.
But just to say about the wiki, it's easier for, I mean, if this is targeted for who are actually building systems as opposed to developers. Basically, if it's not Git, it's really for developers to add to, contribute to, and to do it.
George,
before difficult. Yeah.
George, at least for me, very hard to understand. The sound is breaking off all the time, so every quarter second or so.
So I think the point George was trying to make is that the wiki is easier for some people to edit than upstream docs, and to a first approximation, that's true. On the other hand, we do restrict being able to create accounts for spam reasons, and that involves remembering to ping someone who has admin capabilities on it. I think it would certainly be better if we had an easier way of identifying how to provide feedback for it, even if it's a common developer who makes the change. Because at the end of the day, if there is a change to the defaults, there probably needs to be a discussion as to why that change is a good change. And that should again happen through the normal review process. In particular, you don't want changes that are of the form, in my one specific use case, it is great to do X, because that might be wrong for most other use cases.
Yeah. So is this a bit better?
Unfortunately not.
Okay. Yeah. I do agree that having you us is
attractive.
George, I suggest you type whatever it is you want to say into the chat, because really it's not possible to understand what you're trying to say. Sorry.
Okay.
So what specifically are you looking at here?
So I'm specifically looking at, for example, use cases like very large setups, large servers, still huge servers with hundreds of gigabytes of memory or even terabytes of memory and hundreds of CPUs. What is the common setup in, for example, DOM zero memory size? Is it 64 gig? Is it at least 10% of the host size? Is it, whatever. And does it make sense to limit DOM zero the number of vCPUs, and to which number do you limit it to, one socket or whatever?
To answer those questions from Zen Server's point of view, we actually look at the system and vary it based on install. So we write the command line suitable to the system that it was installed in. We top out at 16 vCPUs because for every perf metric we monitor, things get worse with more than 16 DOM zero vCPUs, which is something that needs working on. But yes, literally every time we go beyond that, perf gets worse with more DOM zero vCPUs rather than better, and that was still true in the Linux 4.19 kernel. We suspect it's something to do with spin locking or something else, but there are bigger things to look at right at the moment. I think for memory size, we top out at 64 gigabytes. Although we have one supported use case where we tell the customer to up that size. So one of the Citrix products is called PVS for provisioning volume service or something like that. It's a brand name of a different bit of Citrix, but we have a feature for doing read caching of base VM images. So particularly when you've got a VDI setup, you'll have one gold image and 1,000 tiny derivations of it. So we specifically have some features for caching the read-only base images, and that will consume as much DOM zero memory as available. So I think we nominally support up to 256 gigabytes assigned to DOM zero for that purpose.
Do you use dedicated CPUs for DOM zero or just basically free scheduling of the hypervisor?
So we actually have a patch written by George ages and ages ago. So every major time slice, we reevaluate DOM zero's weight in the system. So DOM zero is permitted to monopolize up to 50% of total CPU runtime. So yes, George, we still have that. On a large system where there are more than 16 CPUs, it makes no difference. Basically, DOM zero can run all 16 vCPUs at 100% if it needs to. Obviously, if it doesn't need to, it yields, and you get a bit more space there. On smaller systems, it is configured so that it can monopolize up to 50% of the currently running system. So if DOM zero's got 8 vCPUs and there are 8 logical threads in total, DOM zero can only max out 4 at a time.
Okay.
So We have that, and it actually makes a lot of sense in a number of cases, and it is not something that I have seen any equivalent to upstream.
Jürgen, it's Artem. I have a question. Are you targeting only like big server use cases, or we can also think of like having embedded devices which are like on a totally opposite side of spectrum use cases as well, which is also having its own tweaks in Zen configuration?
So my pain point are big servers, but I agree that we should absolutely cover, for example, embedded systems as well. So embedded systems shouldn't be second-class citizens in this regard. If there are tweaks which make sense on embedded systems, we should absolutely document them.
Yeah, there are a lot. Yeah, okay.
So, Andrew, regarding the CPU usage, so our largest customer running a cloud of, I don't know, about, so it's 5-digit number of hosts and very large hosts.
We have a couple like that as well.
Yeah, so they consistently use vCPU pinning for DOM0 to basically one socket, and normally don't allow any other domain to run on this socket. So I don't like pinning, of course. I would favor, for example, using CPU pools.
So would I. This is not something we've actually broached yet in Zen Server. I would like to have enough free time to try and do it, but again, other things take priority.
Yeah, so back at Fujitsu, when we introduced CPU pools for this very reason, basically, we had rather good experience with CPU pools because you can easily split up the server, basically, and change the split dynamically and have some can assign easily high priority get the resources they need without using pinning.
Yes, I agree that this is a lovely idea, but until it is rather easier to use out of the box than currently, it's not getting much use.
Yeah, unfortunately, I agree. So vCPU pinning is no issue for you, or do customers use it?
For complicated reasons, we do have some support articles that say, hey, there's this thing called Tune vCPUs that will do magic stuff under the hood, and it might pin or it might not, depending on what you've got. I would largely ignore that. The vCPU pinning is necessary in some development cases, but I would certainly suggest that we advise against it in production cases. If it makes a difference in production, there ought to be a better way of making the same thing happen, I'd say.
Okay. So
just real quick, sorry. So for vCPUs pinning, sometimes there's security reasons why we may want to do that. We're willing to take the penalty if there's a penalty, but we want to pin them for security reasons.
For which security reason?
If we want to ensure that certain code is executed on a dedicated CPU and not shared across different trust levels.
Yeah, this would cry for CPU pools again, I think.
Yeah.
Because then the scheduling can still kick in, but the guys would be limited to specific CPUs. physical CPUs.
Also remember that on x86 there is no such thing as something restricted to a subset of the system because the cache is coherent across everything.
I don't quite understand how CPU pool is better here. If you know that you want only your vCPU to run on CPU A, then why do you need the CPU pool here?
Because
sorry, is this any better or no?
That's sounding a little bit better. Try talking for a little bit longer.
Just the basic idea is that if you have ping, it just there's no right to scheduling algorithm that just dates and the sort of balancing the fairness stuff that also understands pinning. Basically, it's just because they're complicated. And the reason CPU was basically invented was to allow to partition off, like, so, CPUs, anything you want to, and balancing and everything will work just fine within that system. It makes sense. So if you anything where you say, domain sets of domains must never ever run on CPUs with these sets of domain, then CPU is probably a better option. Pinning would work, but it just really screws up all of if any weights or any of that setup. It just screwing up. I see.
Okay. Yeah, it's probably something we need to take offline. Okay, fairness. Yeah, that's... So long you pin everything, I guess that's fine.
Okay. Okay, the next thing are for very large systems. I'm not sure whether DOM0 standards are really good enough. For example, the maximum grant map check pages. Is it enough when you have lots of domains? Or if you have a very large domain needing lots of PD devices and stuff like that. So
we've certainly encountered problems before with DOM-U not having enough grant table space. I don't think we have yet encountered a system where DOM0 has run out of map track space. That's even running things like our 1000 Windows tests.
Okay.
I do certainly agree with the general problem that having one fixed limit for grant and event size is not a clever thing to be doing in the slightest, and that does want to be a dynamic calculation in the tool stack based on the number of vCPUs and the number of devices expected to be passed to the guest, either up front or dynamically later on. DOM0 is hard, but on the other hand, frankly, DOM0 we can just give the maximum to. It's not like DOM0 is going anywhere. If it needs to use the maximum, it ought to be able to use the maximum, because you don't want to interfere with the system just because DOM0 has hit a limit, or hit an arbitrary limit.
Yeah, another possibility would be to make it not a hard limit, but one which can be modified at runtime, right?
That has a few complexities to it.
Yeah,
if it's an off.
I know.
The thing one of the most important things is not having dynamic failures of the virtual machines, which is why I am pushing so hard to do things like memory allocation in domain create and vCPU create, based on input into those hypercalls. Partly it reduces the complexity in the hypervisor because we're not doing things dynamically, and it removes the number of cases where we can fail midway through the guest trying to do something and are left with no option other than crashing it. If we had some asynchronous offline, well, okay, offline's not a good word, asynchronous way of saying, hey, please double the number of event channels on this domain, and do that as a tool stack control plane operation, then yeah, it might be quite heavyweight. You go along, you pause the VM, you try and reallocate some new structures. If that control plane hypercall fails, fine, you revert back to the old one. But that means you've got a control plane operation that can fail, and the tool stack has to deal with that rather than leaving it for the VM to explode upon.
Yeah, absolutely. For example, expanding the .0 maximum of grant map track pages, it will succeed or not, but the old pages won't be gone, right?
Yeah. Although, irritatingly, that probably can't be a DOM cuttle, because at the moment you can't issue DOM cuttles on yourself for good reasons. So if we're going to make that work, it might need something a little bit custom to work with DOM 0.
Yeah.
No,
Maybe
I'm sure.
hypervisor FS.
Yeah, but the problem is you've still got to pause DOM 0 in DOM 0 hypercall context, and that's why we normally prohibit this. We can certainly make it work. It might have to be deferred to a tasklet or something. But
why do you need to pause the domain for increasing the number of event channel?
Because you've got to resize a structure in Zen.
But the structure are already dynamic. For the event channel, we don't allocate everything.
The maximum upper bound, yes. Well, you've got to reallocate the bucket pointer, because that is fixed. That one currently is fixed at a size equivalent to what gets passed in at domain create. Filling in the bucket pages is dynamic, but the main bucket array is not.
Okay.
I think we'll have similar issues with grant table. Of course, we can make these work. These are not insurmountable problems. But...
Okay. Another question I'd be interested in is, do you use KDump kernel on a regular basis? Because
yeah, it is unconditionally there, configured and available, and irritatingly taking up 128 meg of space, because you can't cram systemd into an initRD and anything smaller than that.
Yeah. Do you have issues as well that on different configurations you need different settings and have to test it and it can fail and whatever? Because we have customers that claim that KDump is a big pain for them.
We do test KDump. We test it quite a lot, including various configurations in boot from SAN configuration. So that's why we have systemd in there. Basically, we duplicate the root disk config into the kdump init rd, because when you're doing boot from iSCSI or boot from Fibre Channel, you need the kdump kernel able to bring up those, re-establish those links, and there's no actual disk in the server you're booting on. And we found it was much easier just to take what we've got in DOM0 already, configuring that, than try and work around it in a small bash script in the kdump environment. Similarly for the networking, I think it's not enabled by default, but there is a way to get the kdump environment to reconfigure so in a Xen server, we have a thing called the management interface, which is the network that Zappy speaks on by default. And it's usually one single network interface in the system. So we have a way to reconstruct that as well. As for the actual kdump testing, it's quite hit and miss. We have found an alarming number of general CPU bugs doing this. In particular, there is one common type of Intel server where if any of the CPUs in a socket disagree on whether it's configured in XAPIC or X2 APIC mode, you can't target half the cores. It depends on whether you've got an odd or an even X2 APIC cluster ID. So we have some gross logic to try and guess what the kdump kernel is going to configure APIC-wise and leave the system like that, so that whichever CPU it crashes on, it can actually send interrupts to itself, because that doesn't work terribly well. Another case that we've got that we have discovered the hard way is that if you ever crash because of a GPU going wrong, you are typically transitioning from Xen into the kdump kernel under a hailstorm of NMIs. So we transition there in NMI context, because otherwise an NMI at the wrong time will take the entire system down and you'll never run the kdump kernel. I think newer versions of Linux do now support handing off the IOMMU. And that's an important thing, because you can't, I think at the moment, upstream Xen by default turns off DMA remapping, and that goes horribly wrong. There's a non-default option that we upstreamed a while ago to not do that, but it depends on the target kernel knowing how to take over with an active IOMMU, which Linux does do now, but certainly didn't in the past. I'm led to believe that there is an attempt with Linux to actually make the kdump entry a proper API in the kernel, at which point we've got something better to code. We've got a better spec to code against than simply saying, here are a ton of options, you've got 50 of them to configure based on which version of Linux you're using, or indeed alternative if you want. So yes, we are heavy users of the kdump kernel, but it's certainly not easy.
Okay, so you similarly then as are experiencing problems from time to time at customer side, right?
Yes.
Yeah, okay. Yeah, I think mitigations and things like that, that's just basically customer taste on what they want to mitigate against.
Do you mean speculative mitigations there?
Yeah, so the normal, the last 3 years, basically.
Yeah, we have a lot of hit and miss from customers there. We have we have the people who say they absolutely must be secure, and can we please make it faster? And the answer is sadly no, but they don't like that answer.
Yeah, so our main problem are mitigations and incompatibilities when, for example, doing live migrations between different CPU types and stuff like that. So from an older to a newer CPU or the other way around, and different microcodes and things like that, and this is a big pain.
So a lot of that is covered in the work that Roger and I are currently doing with the with the leveling there. But yes, migrating between systems with different logical microcode revisions on it is guaranteed to cause problems.
One of the big issues are large guests, as I already said, with the number of event channels, the number of grant pages. And
so I think guests in general need a configuration of event channels and grants proportional to the number of vCPUs and the number of virtual devices they've got. How exactly they are proportional remains to be seen, but I mean, fundamentally, there's a reason why you've got file descriptor limits in regular processes, because one size does not fit all.
Right. And another issue which is coming up here and then are the type of backends, especially storage, of course. So which backend type to use, QEMU or kernel one, and if QEMU, which one, QDisk or QCOW or whatever.
So we're a little bit different there in that we have a totally custom storage stack that doesn't use any of the above, really.
Okay.
The ToolStack working group has been looking to try and do this in a slightly less gross way, because frankly we'd like to upstream bits of it, and there are other people in the Zen community which would like bits of it. We've got we're now at Storage Manager version 3, which has actually started to be a fairly sensible way. It's mostly for managing your different types of storage. The complexity there is in getting the abstractions right to begin with. And we've got a lot of them. We've got, for example, we've even got a GFS2 option, which was done, but there are a lot of individual plugins for proprietary backends. So that was something discussed by the ToolStack working group, because the agreement is that basically what exists at the moment upstream is not great. Basically, it's left entirely in the user's own hands. And
Right.
even networking is done to a first approximation, but disks are still quite hard to set up even with what exists.
Yeah, I think especially when you consider live migration using LVM and whatever, so all the storage allocation and the sizing, maybe migrating storage to another server or whatever, so to another fiber channel loon and so on, is really not supported very well, right?
That's basically non-existent. As far as Zen Server goes, we've got a thing called TapDisk, which was based on BlockTap originally. It's a user space backend. So it's a user space block backend that mounts something from DevMapper, but has full logic for doing things like VHD chain coalescing and merging and snapshot creation and the ability to move multiple backends, which is how we do migration of a VM with its storage changing between storage repositories. But yes, that, as I said, the ToolStack working group likes the idea of some of this, and we'd like the idea of trying to upstream it better than it currently is. The majority of the complexity is around the management of the metadata around it, not with the actual mechanics of making it happen.
Yeah. Okay, I think time is over basically. Andrew, I appreciate your input a lot, and I think we should continue this on XenDevil and maybe start putting together a document or a document tree or whatever covering most of that, right?
Yes, I think that would be a very good thing to do. Something I have talked about for a while, and of course I have had zero copious free time to do it in, is trying to put together a couple of lower level documents concerning things like the life cycle of a DOM ID and how VMs boot and how you configure stuff. Because there is a huge, every time you look at Xen users or the main Xen IRC channel, you've got people confused by how do I boot a guest? What does it do? Do I use pvgrub? Do I use pygrub? Do I use something else? So what I wanted to do was to try and put together some documents like that that explained some of the mechanics of how we work with guests. And built on top of that, you can then easily say in this table of defaults we're affecting that number over there or that thing there. So I mean, Ian's just brought something up on the chat to do with the default consoles, and I would agree that the default consoles are totally bizarre and in need of improvement.
Yeah.
So,
basically, thank you, everyone. It's been a good day, also conversations. So we're going to have a virtual pub thing in the Fairfax room.
Okay, I think George is already closing the day. So,
in which case we should go and do that.
Yeah, right. Okay, thank you very much.
Thanks.
Bye.
Bye.